Let's use tangent in an applied context. Suppose a rocket is fired from the ground at an angle of 0.3 radians relative to the ground. We'll assume that the rocket travels in a straight path. Let's start by drawing a diagram of this. So we've got the ground. We'll assume the rocket fires from right here. So the rocket fires there, and then it travels in a straight path, goes on forever. And the angle fired is 0.3 radians. So the angle that the rocket's path forms with the ground is 0.3 radians. Since the rocket travels in a straight path, this path that it travels on is a line, and we can actually determine the slope of that line using the tangent function. So the slope, we'll just represent the slope of that path as m. The slope of that path is equal to the tangent of 0.3. So the output of the tangent function will give us the slope of that path. And this value is about 0.31. So what does this slope tell us about the situation? If we let x represent the horizontal distance the rocket has traveled since it started moving, and we'll let y represent the rocket's height above the ground, then the slope of about 0.31 means that anytime x changes by some amount delta x, y changes by an amount that's about 0.31 times as large. So the change in y is about 0.31 times as large as the change in x. So this is just our meanings for slope. We can generalize that and say that delta y, the change in the rocket's height above the ground, is always equal to tangent of 0.3, which is about 0.31, times as large as our change in x, which is the change in horizontal distance from the launch point. So this is a formula that how we can use the tangent function to relate changes in x and y, or changes in horizontal and vertical distance. So let's assume the rocket travels 50 yards horizontally from the launch location. We want to know how high it is above the ground. So if we draw the situation, we've got the ground, we've got the rocket's path. We know that the angle is 0.3 radians, and the slope of this path is tangent of 0.3. And what we're given is the rocket has traveled 50 yards, so 50 yards from its launch location. What we want to find is the rocket's height above the ground at that moment. So right now the rocket is right here, and we want to know how high it is above the ground. Since the slope of this path is tangent of 0.3, the height of the rocket above the ground is the slope, tangent 0.3, times as large as the change in horizontal distance, which is 50. So that height above the ground is tangent of 0.3 times 50, which has a value of roughly 15.47. So the rocket is about 15.47 yards above the ground. Okay, so what if the rocket is 100 yards above the ground, and we want to know how far it is horizontally from the launch location? So again, we draw the situation out. We've got the ground, rocket's path, and what we know this time is the rocket at some moment is 100 yards above the ground. And we want to know how far the rocket has traveled horizontally. Now what we know is the slope of this line is tangent of 0.3. We decided that this change in vertical height, 100, is going to be tangent of 0.3 times as large as however far the rocket traveled horizontally. So this is delta x, what we're looking for. So in this case, this change in horizontal distance from the launch location, delta x, is equal to 100 divided by tangent of 0.3. And that has a value of approximately 323.27. So if the rocket is 100 yards above the ground, it has traveled about 323.27 yards horizontally from the launch location.